Okay, hello everyone. I think it's time to get started. And my live talk will be about the SubScript project, which is an extension for Scala programming language that adds a bunch of new syntax to it for working with processes. So this is how I will structure this talk. First of all, I will introduce this language because probably most of you have not heard about it. It is under development. Then I will give a few examples, very simple ones, to introduce what it can do. And then I will outline our plan for the future. So what is this language? It is an extension to Scala programming language that adds a bunch of new syntax to it, and this syntax is inspired by the algebra of communicating processes, which is a mathematical theory for describing processes. And our aim is to simplify the event-driven and concurrent programming and all the programming that deals with any kind of process by introducing this mathematical theory. And here is a brief history of this syntactic extension. We have started as a plain Scala library, which described what a process was, or we call them scripts in SubScript. And the syntax for SubScript was defined in a custom fork of the Scala compiler. So we modified the parser and typer phrases in order to get our syntax working, because it's rather non-trivial and standard Scala features cannot provide it. But this approach was not very intuitive, not very scalable. It was hard to get started with the language. So currently we have moved from this approach, and currently we are using the standard compiler. We are using a preprocessor based on a parser generator library called parboiled. This parser generator library is called from an SPT plugin before the compilation takes place, and rewrites all the new syntax to valid Scala calls to the call library. And as a result, it is very easy to get started with the project. You can start by simply 3 lines in the build SPT and 1 line in project/build SPT. So this was a brief introduction of the history and the definition of the language. Let's see what it can do on an example. Here is an obligatory hello world example and the description of what it does. I have included here a short and verbose version. Both of these versions have these 3 imports at the top, and they basically activate SubScript. By default, our extension is deactivated for each source. You need to activate it using these 3 imports. In the short version, we are using this SubScript application trait in order to invoke this leaf as if it was the main method of an application. So leaf is a script. A script is a specification of a process. And this script consists of 2 operands, of a body that consists of 2 operands. First operand is one call to print a line, and the second operand is another call to print a line. And they are unified, they are glued together by this space, and space in SubScript is a sequential operator. So basically what happens here is that hello gets outputted, and then in sequence world will get output. Here is a verbose version, but I will not stop for a long time in it because I don't have much time. Basically what happens here is that we see how this SubScript application works, how things work without SubScript application. So we manually run this script called leaf. And we explicitly specify that printlns are plain Scala code. It is not part of SubScript, it is part of Scala. So hence this fancy prefix here. So you have already seen this sequential operator that is a space in our hello world application. So we have a bunch of other nice operators to allow various kinds of processes. We have 4 flavors of parallel operators that are inspired by Boolean logics. So basically a process can fail or succeed, and these states are analogous to Boolean true and false, hence 4 parallel operators. We have a choice operator which allows us to choose which particular operand to run according to some specified conditions. We have a disruption that allows the right-hand side operand to disrupt the left-hand side operand. And we have various kinds of conditional operators if then else for Boolean, and do then else for processes, success and failure. I have already said that success and failure are analogous to Boolean true and false. Also, we have very nice capabilities for passing information from process to process. It is called a data flow. We can specify which value should a process take using this caret syntax. We have very much a lot of flavors of carets for various cases. And here we can specify how to pass this result value of a script message to this println function, which is an ordinary println function. Okay, one more complicated example is graphical user interface GUI application, a swing application. In our case, it is a so-called high-test application that is available in our repository if you are interested. And what it does is that it implements a naive approach to test one's eyesight. Basically, what it does is that it displays a bunch of letters with different font, and the user tries to guess them using a keyboard. So the actual point is this lib script. The lib script is responsible for specifying, for initializing the GUI. We use a custom thing here, and white line here is a sequential operator. And here we have these square brackets. You can treat them as round brackets for normal mathematics. They specify the priority of the operands. So inside these brackets we have two operands glued with this parallelism or parallelism operator. So basically what we have here is that this new wait screen will be present. Wait screen is basically a progress bar. This progress bar will be present until we initialize our data. And init data, what it basically does is that it establishes a connection to a database. Once init data is done, because of this for parallelism, once it has success, this wait screen will be cancelled, and the data from init data will be passed in the data flow because of this caret operator. So these repos which define the connection to the database will be passed along to the next script, to the next expression. And this next expression basically executes the program. And I won't describe precisely how we come to this test frame, but we come to this frame as a result of this execution of main screen. So we display the main screen, and the user presses the button test, and this test screen appears. Why describe this test screen? Because it is what we call an object algebra approach. And this test is both a process and an object. It can behave as a process and an object. It extends a particular trait from our core library that allows it to behave as a process. What this trait obliges it to do is it obliges it to implement this lib script that will define the logic of this object process. So in the original trait, which is by the way the ancestor of this frame process, this script lib is an abstract script. So basically, you can think of scripts as of fancy methods, because this is what they ultimately rewrite to. Actually, it is the behavior is quite simple and readable. We have here a disruption operator, and it basically tells that we should execute the main execution flow until the user presses the cancel button. And the main execution flow is a sequence which tests first the right eye and then the left eye. And this time the caret tells us to write the results of the testing of each eye in a typo. And 1 and 2 are the positions of where to write the results in this typo. And here we have a sequence that that starts the test. Basically, we have some stuff outputted on the screen. And then here, this line deserves particular attention because it is a choice operator here. And basically what it says is that the program here will wait for the user to press either enter on the keyboard or OK on the GUI as a button, and then progress. Alright, so these were two very quick examples, and now a few words about future development, future plans, and if maybe someone is interested, how to get started with using our project, experimenting with it, and maybe contributing. During our development of SubScript, we have discovered a bunch of very interesting areas where it behaves, where it really shines. First, these three areas are user-computer interaction, prototyping, and simulation of various processes. What is common in them is that they all involve very complex processes. When you have the user in your decision loop, it always adds very much to the complexity, because a human is much more complex than any program, and you might want to predict what can be done in this program by a user. Also, we are planning to expand to the JS area so that it will be easy and possible to describe web applications using SubScript. And also, a good idea would be to integrate our language in Dotty, and maybe even integrate it in a very generic way so that anyone can redefine the syntax of Scala in any way they like, just like we did it in SubScript. It would be nice to generalize our solution. Alright, now a few words about how to get started if you are interested in the language. So maybe you are aware of the projects like Ruby Koans, Scala Koans, Python Koans, and so on. They are basically puzzlers that teach you the language. And here we have our own version of Koans that basically all this a bunch of exercises to do, which teach you the language in a very elaborate way and allow you to try it out in place. So it is very nice to learn by doing. Also, another interesting thing that we have is this cheat sheet. It is very simple. It is just a summary of all the features we have in the language. Why I'm talking about it is because SubScript has a lot of features, and you might be confused and say that it would be hard to remember them all. And this is why we have this cheat sheet. Finally, all of these materials and more are available via our homepage and our official website. We have a GitHub homepage and an official website here. Well, if you are interested, you can look at my GitHub on the website of the conference. I will upload the slides on SlideShare. I have already uploaded them. You can look at them and follow the links and get all the materials to get started. Also, if you are interested, please feel free to contact us. We will help you to get started. Well, thank you for your attention. I don't know whether there is time for questions.
Any questions?
I have a question. Why you need change the language? Because, for example, after model we have classes, model classes, and also we have transfer offer, which model CSP, communication sequence process models. Yes. Why at the back? Why change the language? Why not provide something in language which will increase your user base definitely?
So if I understood you right, you're asking why modify the language syntax and not just have everything as a library, right?
Yes.
The whole point is that we are trying to make a DSL to simplify the process description. The problem with the current libraries and languages is that they don't really allow you to describe complex processes without running into non-obvious syntax. For example, Scala Swing it uses this reactive approach to specifying the reactions to buttons and other elements, and it is rather non-obvious. And here we have an example how we specify the reaction to a button in a very seamless way. So here we have this choice operator that selects between the OK button and an Enter button, and only when they are pressed, it progresses to the next line. So in effect, doTest is a reaction to this either of these events, and it won't be possible to do that in a very easy and obvious way using plain Scala.
I can say that it is possible. No, I think that it's possible to embed and to write this Scala, which will transform this. This maybe by Scala virtualizer. Maybe look at the approach. Okay, thanks.